there are trends in the periodic table besides those periodic common characteristics. And this is useful because we can look at a periodic table and compare two elements and know something about them relative to each other. So one of the things that we're going to talk about, there are others, but we're going to talk about a couple of them. Metallic character. How much like a metal is this element? So metallic character decreases as you go up a group and decreases across a period from left to right. So here they're showing as you go up, if you go up a column, metallic character decreases. As you go across, metallic character decreases from left to right. I don't know about you, but I have a hard time remembering relationships like that. I can't remember that, and I really don't expect you to remember that either. So I'm going to show you how I remember this. We've talked about metals and nonmetals, right? Where are the nonmetals? On the far right side, these yellow ones. And these are the metals. So if I'm going across the row this way, here's metals, 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 semi-metals, nonmetals. Is it getting more like a metal or less? It's getting less because I'm actually going from metals to nonmetals. Metallic character decreases as we go in that direction. Isn't that easier? And then if we go up and down, it helps if we look at one of these rows right here. So if we're going up, here's a metal, semi-metal, semi-metal, nonmetal. As I'm going up, the metallic character decreases. The elements are less metallic. So if we were to compare two metals like chromium and nickel, which would be more metallic? Chromium, because it's over to the left. It's more on the metal side. We have some examples here. No, we don't. Another trend is atomic radius. Well, does anybody have any questions about metallic character? And the kinds of questions that could be asked were, I give you two elements and ask you which one is more metallic. And you look at their relative positions in the periodic table to decide. Another trend is atomic radius. This is the size of an atom. So the trend is that atomic radius decreases as you go up, and it decreases as you go across from left to right. That's the same pattern as metallic character. Okay? But let's look at why this happens. So atomic radius would be the distance from the nucleus to the electrons that are farthest away from the nucleus, the outside of the atom. And it's helpful to visualize atoms as spheres. So I think of an atom as like a ping pong ball or something, and some of them are stuck together as solids and some of them are floating around in the air. They're little balls, right? They're actually not solid balls, but we picture them that way. And so here's a picture or a diagram showing relative sizes. We see as we go from lithium to sodium to potassium, rubidium, cesium, they're getting larger. And this should make intuitive sense because how many protons does cesium have? I can't read that periodic table. Cesium has 55 protons, right? And lithium has 3. So cesium has 55 protons. It also has 55 electrons. And there's a bunch of neutrons in there too. Lithium has 3 electrons and 3 protons. It just makes sense that it's smaller, right? So as you go down in a column, it gets larger, or the way this is saying it, as you go up, it gets smaller. The other trend doesn't make a lot of sense. As you go across, they get smaller. And this is one that's a little hard for me to explain to you because we're not covering some of the more detailed aspects of chemistry. So I'll just give it a shot, and if you don't understand my explanation, then just go with the memorizing thing. It's the same trend as metallic character. If we think about sodium and chlorine, sodium has 11 protons, chlorine has 17 protons. Because of how electrons are arranged, their electrons are roughly the same distance. But because chlorine has a higher charge on the nucleus, it pulls its electrons in farther than sodium does. And so what happens is as we go across, the charge on the nucleus increases and it pulls the electrons in. And so we see that trend as we go across. Now they left out the transition metals because they don't follow patterns very well. They're kind of like 6-year-old boys. They don't follow patterns well. Any questions? Oh, here we have some examples. Which element would have the larger atomic radius, calcium or beryllium? So you're going to have to look at a periodic table. Calcium's bigger. Why? Because it's further down, and the trend is things get smaller as we go up. So calcium would be predicted to be larger. How about sulfur or aluminum? Aluminum. And that's one that doesn't make sense unless you think about the electrons and the protons and stuff. As we're going across, they're getting smaller because the charge on the nucleus is increasing and it squeezes in. So aluminum's bigger. Chlorine or potassium? Potassium. Potassium is in a lower row than chlorine. Beryllium or nitrogen? Beryllium. Nitrogen is what we want to say because nitrogen has more protons than beryllium. But they're in the same row, and as you go to the right in the row, they get smaller. That's a hard one. Any questions?